So I'm audible. 1, 2, 3, mic testing. Hey guys, welcome back to the channel. So today we'll be again completing the web optimization part that we left earlier. So before that, let me confirm if my stream is audible to me. Just a minute. Give me 1 or 2 minutes. Let me check the stream. I'm facing some technical issues on my microphone. So is audible to me. Yeah, this is audible. Yeah, fine. Just a minute. Give me 1 or 2 minutes. Definitely, it's working fine. It's working great. So yeah, let's go back to the stream. Also need to get a headphone, I guess. At this point. Okay, so this is good. This is good. And back. And critical. Where were we in the last? Okay. So we talked about web performance in the last video. Understood the critical rendering path, optimizing resource loading. Yeah, did we do that? No, I think this is where we begin today. So in the previous model, some theory behind critical rendering was explored. How rendering block, parser blocking resources can delay page initial rendering. Now that you understand some of the theory behind this, you're ready to learn some concepts, some techniques for optimizing the critical rendering path. As the page loads, many resources are referred within the HTML that provide a page with its appearance and layout through CSS as well as interacted through JavaScript. This module, a number of important concepts related to these resources and how they affect page load time are covered. Render blocking. So we actually covered render blocking in previous live stream as well. So we'll just quickly go back. As we discussed in the previous model, CSS is render blocking resource as it blocks the browser from rendering any content until CSS OM is constructed. So that is true. The browser blocks rendering the prevent of unstyled content, which is unresolved from a user experience standpoint. Browser blocks rendering the prevent of a flash of unstyled content, which is unresolved from user experience standpoint. I do not have any idea about this. Maybe just take a look at the video. Flash unstyled is when you see a brief flicker of page content without any style applied to it. Refresh this page in case you missed it. CSS is render blocking by design. Placing any style sheets in the head will block the HTML parser until the style sheet is downloaded and parsed. Yeah, that is true. If you add anything into the style sheet, that will be CSS blocking. That is the render blocking for the CSS itself. In this demo, the style sheet is placed outside the head and placed before the closing body. The browser discards CSS file after parsing and rendering the HTML, resulting FOUC. So that is the reason we don't generally apply style sheet, that the link attribute, whatever we have, in outside of the head tag, because that will create a flash of unstyled content. I mean, it's like a brief flash that we can get. So I don't think so that is good. So in the precedence video, there is a brief FOUC where you can see the page without styling. Subsequently, all styles are applied once the page has finished loading from network, and unstyled version of page is applied. Immediately replace the styled version. Okay, that is fine. We understand the FOUC. So parser blocking. So we also covered parser blocking in the previous stream session. So parser blocking resource interrupts the external parser such as stream element without a sync or defer attributes. If the parser encounters a script element, the browser needs to evaluate and execute the script before proceeding with parsing the rest of HTML. This is by design. A script modify or access the DOM during a time while it is still being constructed. When using external JavaScript files, the parser is blocked from when the file is escorted until it's downloaded, parse and execute. When using inline JavaScript, the parser is similarly blocked until the inline script is parsed and executed. Okay, so we covered this in previous stream as well. If you don't use async or defer with the script, then this is parser blocking. And if you use inline script, then that is also parser blocking. So we learned about preload scanner as well. So preload scanner is browser optimization in form of second HTML parser that scans the raw HTML and fetch resources where the primary parser would otherwise discover them. For example, the preload scanner would allow the browser to start downloading a resource specified in an image element. Even when the HTML element is blocked while fetching and processing requests such as CSS and JavaScript. To get advantage of preload scanner, critical resources should be included in the HTML markup sent by server. For instance, loading pattern are not discovered by the preload scanner. Images loaded by CSS using background image property. These are not, of course, we actually covered this, I guess, in the previous session. So I think we're just going to keep over the preload scanner. This is just one more scanner that browser provides you. While your primary parser is blocked, we can use a secondary HTML parser to scan the HTML response, whatever we have. And if one is blocking due to, if there is a JavaScript and it is blocking, it will, the other parser will still continue to scan the files. And if it gets any resources, then it's going to stop at that point. It's going to continue sending the request, I guess. That is what it's going to do. Okay. Next is CSS. CSS defines the presentation of a layout of a page. As described earlier, CSS is a render blocking resource. So optimizing a CSS would have considerable impact on overall page time load. That is fine. Minification CSS file reduces the file size of CSS resource, making them quicker download. This is accomplished primarily by removing content from the source, such as spaces and other invisible character, and outputting the result to a newly optimized file. So if you have a non-minified version of CSS that you use or send, I think that is a very bad way to send this, because this whole thing, the whole stuff can be reduced down to 2 lines. That is minified CSS. H1, H2, something like that. Strip down all the spaces, and yeah, it looks something like this. This entire 12, 15 lines of code can be minified in 1 line, something like this. So that's one good thing, that even if you apply styling like this and there is a common styling between H1 and H2, so this, the color that is common between these two, when minified, it is smart enough to aggregate both of them, and it looks something like this. And H1 and H2 has their own styling, which is this and this. That is pretty smart, and there are bundlers which can do this. In the most basic form, segmentation is effective optimization to improve your FCP and perhaps even LCP in some cases. Tools such as bundlers can automatically perform this optimization for you in production builds. So what kind of bundlers are we talking about? So bundlers tooling report. They have Webpack, Rollup, Parcel, and Browserify. Current results as of past. I think Webpack is the most common, and Rollup is right now taking over it. So yeah, we'll see how this goes. Okay, code splitting, hashing. So that being said, let's go back to the resource optimization. Minification. Okay. So this is done. Remove unused CSS. Before entering any content, the browser needs to download and parse all the style sheet. Time required to complete parsing also includes styles that are unused on the current page. If you're using a bundler that combines CSS into a single file, your users are likely downloading more CSS than needed to render the current page. Discover unused CSS for use the coverage tool in Chrome DevTools. So this is actually a good tool if you use them. Use it. This will show you the coverage, how many of the CSS is getting used, something like this, and then you can decide or remove this particular stuff from your style sheet. If it is not used, then you're actually wasting your own resource. Has twofold effect. In addition to reducing download time, you're optimizing render tree construction as the browser needs to process fewer CSS rules. Yeah. So if you're removing unused CSS, your website is going to load faster and construct faster, and it's going to, I mean, for you, it's a direct impact to the user. So yeah. Avoid CSS import declarations. But missing content, you should avoid import declarations in CSS. Don't do this. Don't do this. Why not do? Why you have to avoid this? How link element works in the import declaration CSS lets you import external CSS within a style sheet. The major difference between these two approaches is that the HTML link element is part of HTML response and therefore discard much sooner than CSS file downloaded by import declaration. The reason for that is in order for declaration to be discarded, the CSS file that contains first must be downloaded. This results in what known as request chain, which in case of CSS delays how long it takes for initial page to render. Another drawback is that style sheets loaded using import declaration can't be discarded by preload scanner. They become late discard render blocking resource. So this is actually very good learning. We should avoid this because of the delay it takes for it to discover. That's the only thing I'm able to understand from this. In this case of CSS, it delays how long it takes for a page to initially render. Another drawback is that style sheets loaded using import declarations can't be discarded by preload scanner and therefore become late discard render blocking resources. Fine. Do this instead. So you want this, instead of doing this, instead of importing styles from another style sheet, like if I have two files, style1.css, style2.css, in the style one, we do not want to import this. Instead, what we can do is in the HTML itself, we can apply link. We can use this particular tag instead. So that is better. And this is what the web dev is saying us to do. Okay, since that is not blocking. And yeah. In the most cases, you can replace import by using this. Link elements allow style sheet to be downloaded concurrently and reduce overall time speed as opposed to import declaration, which downloads style sheet consecutively. Inline critical CSS. The time it takes to download CSS files can increase a page FCP. Inlining FCP, style sheet in current document head eliminates the repetition of CSS and when done correctly can improve initial download when user catches is not primed. The time it takes to download CSS can increase page FCP. Inlining critical styles in the document head eliminates the network request for a resource and when done correctly can improve initial downloads when a browser cache is not primed. The remaining CSS can be downloaded asynchronously or appended at the end of the body element. So majorly is just saying that we want whatever CSS we want to add, we should add it inside the head. That is what been said all along in the stream. So let's get back to the downside. Inlining a large amount of CSS adds more byte to the HTML resource because HTML can't be cached for a long. Means that the inline CSS is not cached for subsequent pages that may be seen in lesson. Okay. JavaScript are most of the interactive on web, but it comes to cost. Shipping too much JavaScript can make your web page slow to respond during page load, and when causes exponential issue. Render blocking JavaScript. We learned this. Async versus defer. We understood this as well. Parser fetch execution. Or parser continues in the defer. In async, parser goes. Okay, so this is what we understood in the previous session as well. I'm not going to continue. I think it's the same stuff. Critical client side rendering. So this is one of the important concept in terms of interview as well. So if you're watching this, then I think we should understand what is client side rendering and what is server side rendering as well. We'll go over this one by one. Generally, you should avoid using JavaScript to render any critical content or page LCP. This is known as client side rendering, and it's technique used to extensively in SPS. That is correct. Markup rendered by JavaScript sidesteps the preload scanner as the resource contained within the client rendered markup are not discarded by it. To delay the download of crucial resources such as LCP image, the browser only begins downloading the LCP image after the script has been executed. Added the element to the DOM. In turn, the script can only be executed after it has been discovered, downloaded, and passed. This is known as script, and it should be avoided. Rendering markup using JavaScript is more likely to render long tasks than markup downloaded from the server. The response to me is effect iteration latency is where we got rendering works. So let's try to simplify this stuff using Claude. Back. Okay, so yeah, of course I'm at home. So I need to log in it again. Back. Okay, so what is client-side rendering? Using JavaScript to create HTML in browser rather than receiving ready-made HTML from the server. So the server-side rendering and client-side rendering is, in client-side rendering, what really happens is whatever page that you generate, suppose this web page that you're saying is already rendered in server-side rendering, it's already rendered by the server and then sent to this particular browser, and the browser just patches the whole thing. If there is JavaScript, it attaches and the page is ready to go, which is much faster, you could say, but it adds additional load to the server. And in the client-side rendering, what really happens is you send the JavaScript, and using that JavaScript, it constructs the DOM on the client side. So this is what it means, to be honest. So if you go to any of the website, let's just say I go to the Boolean Stack website, booleanstack.com. Yeah, site is down right now. Boolean Stack hyphen just v1 prod. I think this one is working. Yeah. So if we go back and we inspect, and let's just see how the network requests flow. We reload this tab and disable cache console, disable cache. Okay. Throttling, no throttling, filters, all filters. There we go. In the first one, we can see that. Let's go back to binary search. Let's reload this page, and this page is getting served from server itself. So these are all the content that we have. Okay, so this is already loading from server, and the remaining CSS is applied later, and the page is looking like this. So we get this entire stuff from server, whatever page we have from the server, and then on the client side we are only just applying CSS styles, and the page is looking something like this, and we are injecting JavaScript that needs to be executed. But the main content of this page, that is whatever there is, like this text and all these things, are coming from the server itself. So due to this reason, it is much easier for SEO scanners to parse this out. Let's say we have SEO engine, let's say Google is scanning this out, so it's able to parse this very easily. The parsing continues well, I guess. So it will help you in SEO ranking. That's it, the server-side rendering. But it also has one additional cost, that we have to maintain the servers. That being said, let's just go back. You understand client-side rendering, that is fine. Minification, similar to minification, file size. I think minification of JavaScript is just whatever text, whatever variable names that we are defining, long variable names, are actually going to be shortened out. The spaces are going to be trimmed down. The rest all are going to be remain same. See, everything is split by semicolon, and this is the reason that people ask you to write semicolon, because of the separation, code separation. Do not, if we write semicolon, it will be easier for us to separate, for the engine to separate things out. In the preceding snippet, you can see the human readable variable script element. Okay, that is shortened, that is it. What is the best way to load multiple CSS file in your browser? Multiple link elements. What does the browser preload scanner do? Detects elements in a secondary parser. It's a secondary parser that examines markup. So why does the browser temporarily block when downloading the JavaScript resource? Block of parsing. Modify otherwise. Why does the browser temporarily block parsing of HTML by default when downloading JavaScript resources? Of HTML by default when downloading JavaScript resources. You see if I remember the bar. Very similar and pausing machine gives more bandwidth. I think this is correct. Okay, let's go back. Assist the browser with the resource hints. Just a minute, chat. I'll be back. Okay. So, assess the browser with resource hints. In the last module about optimizing resource loading, you learned how various page resources such as CSS and JavaScript can affect page speed load. How can you optimize them and their delivery to speed up the rendering of the page? This is perfect. Okay. I think these are all the tags that we have here that we are going to discuss. Optimize them and deliver to speed up the rendering of the page. This is perfect to move into a more advanced aspect of resource loading and the inverse being. Okay, so that is fine. Resource can help developers further optimize page load time by informing the browser to load and prioritize resources. An initial set of resources such as pre-connect, DNS prefetch were first to be introduced. Over time, preload and fetch priority APIs followed to provide additional capabilities. Resource hints instruct the browser to perform certain actions ahead of time. That could improve loading performance. Resource hints can perform actions such as performing early DNS lookups. That is fine. Connecting to the server ahead of time and even fetching resources before the browser could ordinarily discover them. Resource hints may be specified in HTML, most often early on in the head element or set as an HTTP header. For the scope of the model, pre-connect DNS and covered as well as speculative fetching behavior that prefetch provides. The first one is pre-connect hint to establish connection to another region from where you are fetching critical resource. For example, you may be hosting your image on a CDN on another origin. You can anticipate the browser plans to connect to a specific server in very near future, and the browser should open that connection as soon as possible, ideally before waiting for HTML parser or payload scanner to do so. So this is actually very useful, and we can say this particular tag being applied to multiple websites in their head in the link rel equal to pre-connect. What this does is it creates a connection between client and your end client and the server where the resource like images are hosted. So that is actually good. You can anticipate the browser. If you have a large amount of cross-origin resource on a page using for the resources which are most critical to the current page. That is true. and we can see connection started, connection start, failed proxy, DNS lookup, initial connection, and SSL. So this is actually connecting to the server that where the images are hosted. Request response, time to first bytes, duration, this is fine. Whatever is in the red, this is what we are concerned with most. The common use case of pre-connect is Google Fonts. Google Fonts recommends that you pre-connect to Google APIs for the font fetch declaration and the gstatic domains to serve the font sizes. So if we have this as pre-connect, then it will be faster for the fonts to load. The cross-region attributes is used to indicate whether a resource must be fetching using CORS when using the pre-connect int. If the resource been downloaded from the origin user's CORS, such as file fonts, then you need to add cross-origin attribute to the pre-connect int. So that is one thing. The next thing is DNS fetch. What do you mean by DNS fetch? Okay, I think what we can do is we can simplify this particular block. I think these are all tags and we can actually skip this ahead. Maybe understand this is the browser with resource sent. Provide this to Claude because we're going to speed up the process of learning, and we're going to give this particular thing for all and explain the concept to me. This is what I'm going to say. I hope it's able to make the request. Yeah. Yeah, so it's able to do it. So that is really good. And resource hints are instructions you give browser to prepare for things before they are actually needed. Think of it like telling a restaurant, I want a dessert later. They can prepare it. I'm bringing 5 friends. They can set up tables later. And the 5 main resource hints are pre-connect. First one is pre-connect. Connect to the server early. Second is DNS prefetch. Look up domain name early. Preload. Download critical resources now. Prefetch. Download resource for the next page. This is also used in blogging sites. If you visit multiple blogs, then this attribute is actually very critical for us to render. The reason why that is because we are actually fetching the next blog ahead of time. Suppose if a website has 10 links inside it, so we are actually going to prefetch all the links. We can do that as well. That allows us to speed up the time, because as soon as the user clicks on the next blog, the link, hyperlink, it's already been prepared by the browser, already been downloaded, and user is just going to see it. That is actually this tag is very important. Fetch priority changes download priority. Let's deep dive into each. Pre-connect is early connect. That's it. Just a handshake that we are doing. Page loads, browser finds the link, DNS lookup, TCP connect, TLS handshake, and then now download font file. Font finally appears. This is the without pre-connect. And with pre-connect, we are doing this in background, whatever we have. Page loads, user sees this, browser finds font link, connection already ready, download immediately. Okay, so the difference between this and this is when the TCP connection is happening. It is happening as soon as the page loads, and then we are preparing the TCP connection in the pre-connect. But in this, when the browser finds the font link, then it is going to make the connection, which is actually slower, right? The common use case is Google Fonts. That is fine. We are pre-connecting to Google APIs, and then we are going to pre-connect to the gstatic cross origin. Later, when we find the font, this is already connected. I mean, we already connected to both the domains. So now this just downloads the resource instead of making a TLS handshake. So why this is why two pre-connects? Serves the CSS file, serves the actual font files using CORS, users CORS. Okay, that is good. We're not going to deep dive much in this. Add CORS when pre-connecting to that user's CORS. Okay, cross origin. Don't overuse. Only for 2-3 most critical origins. Each connection uses resources. Too many is equal to wasted efforts. Do not want to waste the ton of connection links. DNS prefetch. Lookup names early. What it does? Only does the DNS lookup domain and IP address, not the full connection. DNS prefetch example.com pre-connect versus prefetch, pre-connect full setup, DNS lookup 50 full connection ready. DNS prefetch just DNS lookup only IP address known. So what does it do? What does it really do? Only does the DNS lookup, not the full connection domain to IP. Okay, so we're just whatever domain name that we have, whatever domain name is in, suppose we have example.com, it is going to get the IP address of it. It's not going to create entire connection, but we do have IP address ready. So when the TLS, when we make a request, so this DNS lookup is what creates, is the additional cost. We are just reducing this cost when we do DNS lookup. IP address known, just lookup. This is the entire connection layer. We have DNS lookup, then TCP, then TLS handshake. TCP connection, then we have a TLS handshake, then it's total 250 milliseconds. But when we do DNS prefetch, we are excluding this part. We are reducing the part of 50 milliseconds. So that is a good thing. Use instead of prefetch, pre-connect when you have many third-party domains. Connection might not be used. Want lightweight optimization. I think this is fine if you want to perform a DNS lookup, but I don't know if this is really useful, to be honest, at this point. And I might need to see if how the normal websites behave. Let me open some of the websites that I know. Let's just open Cloudflare. I think these guys pretty heavily do optimization on their end. Let's go back to the Cloudflare, see if what do they have in the head tag. So yeah, I think there should be a relation is equal to alternate, and I have no idea what this means. We'll see that as well. I don't see any pre-connect or that stuff here, at least. Okay. Let me open another website. Let's go to Uber. Let's go back to their software engineering careers. Let's just go and reload the entire stuff. Go to elements, go to head tag. This is what we care most. And see if we have. So they are using async in their script tag. And in link, there must be something, right? I don't see any pre-connect or that stuff as well in here. They're just language specific files, I guess. Okay, so there is one tag they are using, module preload, and they are actually providing a hash integrity for this as well. So that is a good thing. So type it is relation is equal to module preload. What about CSS? What are they doing in terms of CSS? Is equal to style sheet. Let me search this out. Link equal to style sheet. Okay, so are they not loading any styles? I don't see any styles being loaded right here. Yeah, I think their conference is fine. There must be something going on. We need to check it carefully. Let's open another website. Maybe the web dev browser itself. Let's go back and see if how they are building it up. Go to the relation style sheet. So they are using pre-connect, as you can see, for the browser assistant hints, browser with resource hints. So they are using pre-connect, and they are also applying cross origin for gstatic. Of course, they should. And pre-connect is only thing that they're using. In the script, they're using async, like Uber. I have to understand what this alternate actually means, but yeah, and this is for, I guess, what, I forgot what the name of this was. It has one important open graph. Yeah, this is open graph image. This is for when you share something up, we actually get some card thing. That is good. Let's go back to the stream. Okay, so we did this complete. We understood the prefetch. The next one is real world example external links. Smart. Okay. So DNS prefetch. Yeah, we understand the DNS prefetch as well. So next is preload. What does preload do? Force the browser to download a resource immediately, even if it hasn't discovered it yet. So must use as attribute, as style, as image, as font. So with preload, we have to also use the as tag and head link relation style sheet href is equal to styles, and these are the styles that we have. Timeline without using preload. HTML is loaded, downloads the style sheet. Styles are loaded, parsed, and now discovers the component.css, whatever CSS files we have. Start downloading all three, everything is finally loaded. Timeline with preload. So we preload this up, HTML loads, it downloads all files in parallel, everything is ready to load, and it literally saves the time. So that is when a good thing about this. So common use cases, hero images, LCP. So if you have a large image that is loaded in the browser, suppose one large image that is like 2 MB or 3 MB, some kind of large resource, then we can actually use a preload to fetch that image ahead of time, and this can save our time. Seriously, I still don't understand how does this work. I mean, what is the order of preload? How does this work? Is preload being given priority ahead? I'm not sure. I need to check that out. But we do have to specify the as attribute. I think browser needs to know priority and how to handle it. So this is, don't overuse it. We cannot overuse everything, as we should not use everything with preload. Only use for the critical resource. If it is a main hero image or some font family that we are loading, we can preload that stuff. Only preload 2-3 critical lead Discord resource. Prefetch, download for next page. Just a minute. Okay. Prefetch, download for next page. What does it do? Download some resources for next page. Users will visit low priority during ideal time. This is fine, I guess. I think let's understand what this was saying. And preload was fine. Prefetch I already told you. Directive is used to indicate a low priority request for resource like to be used in future navigations. The directive largely follows the same format as preload directive. Navigation uses the value of prefetch instead. Unlike the preload directive, however, fetch is largely speculative in that you are initiating a fetch for a resource for a future navigation that may or not happen. So this is just that. See, when you're using something like prefetch and you're using a link and there is a resource, this may happen that suppose there are links, right? Suppose in this website as well, in this website, this is the link that is there, this is the link that is there, and this is the link that is there. So what happens is, if you apply prefetch to this particular link, let's say, then, and you're loading some styles, then it may happen that user may click that particular link or user cannot click that link. So it doesn't, I mean, it depends on the user's action. If he clicks that link, then he already has the style for that page. Something like this. If that is correct, if I understood it correct. Maybe I'll search this out in a separate Claude instance. Let's see what it really means. I'll just ask it out. Does it mean is that related to link? Like if user is like user can click the link, user Choose to not click the hyperlink. Is it related to hyperlink? Or I just need to confirm if this is related to hyperlink, that normal links that we have, or is just not. Whether it's related to hyperlink. Yes, prefetch is related to links and navigation, but not directly to one way with specific hyperlinks of your page. That is the thing, yeah. You have these links on your current page, that is with the A attribute, but you can predict user will likely visit product next. So if user is likely to visit the product page next and the product page has the styles, that products.css, then you can prefetch those resources in your context in your current page, and when the user navigates to that product page, then he already had that product.css file loaded, product.javascript file loaded, and the parser is just going to execute those. So it's just speculative. I mean, you're just guessing that user will do it. It's not that key user is going to do that. But it's not necessary. It may happen that user closes his browser and that resource is just wasted. So that is fine. I understand this prefetch. Let me open Excalibur. Let's just see. Let's write this down in the Excalibur. So first, let me zoom this a bit. So we have prefetch, preload, DNS lookup, DNS. What was it? DNS prefetch, DNS prefetch, and then we have reconnect. We need to understand the basic difference between all of this. And what was the last one? Fetch priority API. I think this will do at the end. Yeah. Fetch priority API. Let's go back. So, okay, we started with this one. Reconnect, create connection ahead of time. Generally useful for font. I'm just going to write it down. Okay, it's generally useful for font. Use for what? These are used for fonts. Loading up the fonts, creating the connection request for the Google fonts. I mean, if you have, let me just maybe write it down. Fonts. So G static is where it is used. I mean, you can see this in the web.dev as well, web.dev as well, that we have this head, and in the head we have link relation is equal to pre-connect, and we are using cross origin here. That is fine. Next is prefetch. What do we have prefetch? We have prefetch for reconnect, we done it. DNS prefetch. DNS prefetch is the next one. Let's go back. What do we have? DNS prefetch. DNS prefetch. What do we have? DNS prefetch. To do cross origin rather than to perform DNS lookup. Okay. Perform DNS lookup ahead of time. That's it. This is the only use case of DNS prefetch. Next one was preload. Okay. The major use case of preload is to load hero image. Request hero image. Loading. And critical resources or critical resources. And the last one is prefetch, right? So this is the final one is prefetch. Speculative, right? This is what it said. Speculative. speculative lookup ahead of time. So what this means is we are actually guessing that, let's say, user is having, so I'll just draw this out for the specific case that for prefetch, it's something like we have the user. Let me just, we have the user, just a minute. Give me a minute. This with this. Okay. So we have client, and we have, suppose, page A. And in this page we have, this is main homepage of Amazon. In the homepage we have two links, product page, product A, say product B. This product page has its own resources. Let's say product.css. It has, and product.js it has. This is shared among these two, product CSS and product JS. User clicks, user from his homepage has a menu, that is, suppose user sees one card. This is one product. This is another product. This is one product, and this is another product. Okay. User it is linked. These two products are linked. Okay. So these two products are linked. Okay. So from this, user can perform two actions. Either user can go to homepage, and okay, let me just zoom this out. Yeah, it's fine, I guess. So user can go to homepage, and from homepage user can go to product page, or he can just press the exit button and cross out from the homepage. So if user decides to go to homepage and we are at the homepage, we can do speculative prefetch of this particular resource, product.css and product.js, ahead of time, thinking that user is going to visit to product page and we already have the resource for the product.css and product.js. So this website will load faster for him. Let us visit amazon.com, and if you're going to click on this page has its own resource, but we are going to fetch the CSS and JS of this particular page ahead of time in this page itself. So this actually is beneficial in the real use case. Yeah, prefetch is good, prefetch is done. So then the final one is what is it? Fetch priority API. So we can give priority to each resource, whether it's an image, link, or script. We can give the priority. It is particularly important when using for page LCP. By raising the priority of LCP with the attribute, you can improve page LCP. It's fine. Image performance, this is fine, I guess. We're back. So let's just do the test your knowledge. What does pre-connect resource hint do? Opens a connection including DNS lookup as well as connection and TLS negotiation ahead of time when the browser will discover it. This is correct. Fetch priority API specifies the priority. Prefetch is going to, this is pre-connect. This has not stated explicit for any resource the user could need, whether or not they actually need them in future. This when you should use prefetch, right? Okay. Speculative lookup, this is what I said. For any resource or page the user could need, whether or not they actually need them in the future. An explicit preference for reduce data when user has confidence that this is a page intent to user needed by the okay, we don't want, it's not for all resources. We are doing this for the high confidence, and this high confidence is actually very relative term. Okay, we do not want, suppose in this entire page there are many hyperlinks. Let's say we have link for this as well, facebook.com, and this as well, and it's going to go sell on Amazon as well. But it's more likely that user will click on a product and uh, if he's visiting Amazon. So the speculative lookup should only be done for this particular product or few of the pages, not all the pages. That is wrong. This is correct. The user has not stated an explicit preference for reduced data usage. So this is I don't get, but why? I mean, let me just screenshot this out. Let me ask for this specific case. What does this mean? Right? Let's go back to this cloud. Whenever a confidence of the system, if the user hasn't indicated, respect user on limited data plan or circulation, check for data save error, or use preferences. Consider connection type, avoid on slow connection. User preferences. So this is actually a nice one. I don't know what the save data header does. Let's just think how this works, because yeah, we have to think if user has enabled a data saver plan, I think that is when we send less resources, I guess. So yeah, the save data is real browser feature that indicates when the user wants to reduce data usage. Here's how to check for it. Server side most common, save data enable, user wants to reduce data usage, keep prefetch hints, serve smaller images, etc. Clients have JavaScript. If server save data is enabled, save for prefetch document link. Okay, this is good. Other connection consideration. Connection consideration, prefetch, slow 2G. So we're actually whatever the user has, let's say he's on the 2G connection or a 3G connection, whatever he has. If he has slower connection, we want to handle that use case accordingly. And this is what the navigation connection, save data, these all things do. Don't add prefetch links, save to prefetch. If user is on the data saver, we handle that stuff. Otherwise, we can prefetch the next resource. Because let's say user is already is having low data, he has low data, then you don't want to prefetch the resource of the next page ahead of time, because that will be heavy for the user. It will consume a lot of data for the user. That does not make sense. So if user has enabled save data in his file, in his settings, then we want to respect that thing. So we have to handle that case in the server as well. So let's just go back, learn the concept of this. Image performance. This is the next thing we have to do. And we only have like 20 minutes more. Image performance. Image is often the heaviest and most relevant resource on the web. As a result, image optimization can significantly improve performance of a website. This is actually very true, because let's say if you have a website, something like Amazon, so we can see that we have 16 images right here, 16, and these are 32, and there are a lot more. I mean, there might be 16, 20 here as well, and there are lots and lots of images. But I have a good connection. I can say that I have like 200 Mbps of a connection, so that is loading pretty fast. But we can throttle this out to see how really it works, because we can disable the cache, and let's say we are on the 3G connection and how this loads. Let's see how Amazon.com loads when we are on a 3G connection. So see this, everything is blank. These are the placeholder. The images are downloading pretty slow, and these are downloading pretty slow as well. These are just thumbnail images. Then the full images will be downloaded, I guess. It's a two-step process, and the page is still loading, right? The requests are still been made. In the waterfall model, we can see that. Yeah. 40 seconds and the request is still done. It took, and it's still taking a lot of time, I guess. These are all the images that are being loaded. We cannot preview them, but the indication is pretty clear that it's a JPEG files. Yeah, these are all the files that are being loaded by the browser. It's still 1 minute and the Amazon is still loading on 3G network. Yeah. So what I'm saying is image performance does actually matter. One more example I'll give you is of Carvale. If you visit this particular website, it also has a lot of images. In the homepage itself, they have a lot of images. And even if you go on any page, let's say if you go on Hyundai Creta, and we see there are a lot of images, and these are all images are also pre-loaded. And your whatever images that you have actually carry a lot more, has a lot more priority than you think. So images are often the heaviest and most prevalent resource of the web. That is true, definitely true. So there was one thing that I learned that was about the SRC set sizes and compression basically. So these are, in this, what we are going to say is we are going to see that whatever image size we have, suppose this particular website, we are going to place this particular image, and it's how much, what's the size of this particular image? Let's go and inspect it out. This, yeah. So this is around 480 pixels wide. So we do not want any image that is larger than 500 pixels in this case, yeah. That is fine. There are many variables involved in choosing the proper image, making the task of choosing the proper image in every case to be quite complex. When the iPhone was released, the screen resolution was this, and iPhone 3 had a resolution of this. iPhone 4 has a double resolution than iPhone 3. The physical size of iPhone 4 remained roughly the same as the iPhone 3. So, cramping down pixels, this is what it means. Let's just say that iPhone 3 had, this was iPhone 3 and this was iPhone 4. They pretty much look same, but the pixel size that it has, let's say this is what I'm using, background, let's just say this. This is what the size of pixel, let's say, iPhone 3 had. But iPhone 4 had half the pixel size, something like this. Yeah. So it could fit down twice the number of pixels than iPhone 3. Let's say this was iPhone 3. Let's go back. Unit phone. Just a minute. Give me a second. So this was iPhone 3. Then let's go back to see this was iPhone 4. The pixel density increased, but the dimension of the phone was physically the same. So displaying, and this actually goes for every other phone, that we do not know how many pixels that particular phone has. So images may look different, and there is this thing called as device pixel ratio, DPR, that iPhone models has. I mean, iPhone devices have. Every other device have actually. Revisiting the earlier example, if the device has DPR of 2 and the image is displayed in 500 pixel, then the square 1000 pixel is now the optimal size. Similarly, if the device has DPR of 3, then square would be the optimal size. Okay, so this is actually a very critical thing to understand that not many as a developer understand in terms of image, how images are actually injected and loaded in the browser. Everything boiled down to DPR. Simple. It's very simple. Everything boiled down to DPR. Let's say this is your phone. This is the iPhone of 17. Let's say this is iPhone 10. Okay, and this is, let's say, Samsung. Okay. S20. Let's just say S20. Let's take example of S20. iPhone 10 was released a very long time ago, and let's just say Samsung has even less number of the size of pixels are even less in Samsung's way. Okay, so clearly it can cram down more pixels, and this has pixel density DPRS 2 device pixel density, whatever we have, it has 2. And for the iPhone, let's say it has 1. So, and we are loading an image. Let's just say this is the image that we are loading, and the size of this image should be actually dependent upon the pixel density of this particular iPhone and this particular Samsung Android phone, because this is the ideal size of the image that you will load on here, but we require twice the dimension of the image, like something like this image, to see. So these are 2 images. Okay, this is let me just write 500x 500, 500x 100, let's say, and this is twice of this size, 1000x 200. Okay, but they will look kind of same, I mean, in this particular instance, but because it has DPR of 1, the image will look clear in this particular instance. But if for the DPR 2 for the Samsung, this will look clear. That's the key difference, I guess. SRC set, this is where we define zoom level, that is the DPR that we are defining, pixel density 1, 2 and 3. I think 3 is the maximum that we have for now, and I've not seen anybody using more than 3, to be honest. So because loading this image, I mean, it's the same image but with a different resolution. So this is actually taken care via Cloudinary or if you visit the Cloudinary websites. Let's just go to Cloudinary. Yeah, let's go and see how the images are loaded here. This is not an image, this is an image. Read item, image. I think we need an image, to be honest, for this to see. Is this an image? Yeah. So I think the attributes are not defined here, but yeah. I think channel 2x. I think this 2x is what they are triggering the image up. Okay, I actually learned about this when I was in Carvalho, the whole image optimization stuff, and how internally the images are rendered. That is a good thing. And we also have in the end we have file format and file compression, that if we can use WebP, we should use WebP for compatibility and faster load, because this is actually lossy, I guess. This is lossy. WebP is lossy. Is WebP lossy? Is WebP lossy? I think WebP is lossy. Yeah, can be lossy or lossless. You can choose which type of compression to use. Okay, so it can be configured. That's a pretty good thing. So for WebP, it is lossy and lossless as well. So we can choose to configure it. And I think WebP is not used much in the browser, but let's just see, is WebP lossy? WebP is lossy format, but also supports lossless compression. Okay. So this is a good thing, and we actually do this stuff in picture attribute. In picture we have image in SRC tag. This is just a okay. So depending upon the viewport width, we define what, and the DPR, we show the image to the user. There is not one single image that is being shown to the user. It can be multiple. I mean, what we do is we create one single image. Let's say you click a photograph, and that is around 1000 pixels. That is around 2000 by 2000 pixels. So depending upon the resolution of the device, we actually smartly show the image, and depending upon the DPR that user has, the DPR of the smartphone that user has, we actually showcase the image. We actually inject and show the image to the user. It's not like that 2000 x 2000 pixel image should be shown to every single user, because that does not make sense. If the user has 300, if user device with is 320, then it doesn't make sense for us to show him 1000 2000 x 2000 image. We can actually lower it out. That is what it means. We can show him the lower density image. That is completely fine, and that is what the performance actually means. We also have lazy loading. This tells browser to load when appears in the viewport using the an attribute lazy load that does not download the image until it's near the viewport. So this loading equal lazy tells the browser that, let's just say if you are loading Carola website and there are images down at the bottom of the page as well. So we don't want these images to be loaded right now. And let me disable the 3G, no throttling. Yeah. So these images that are at the bottom of the page, we don't want this to be loaded ahead of time. So that's why we can say that loading equal to easy. What about decoding? It's about how it should decode the image. Well, if a sync tells about that image can be decoded asynchronously, firstly improving the time to render. So sync tells the browser that the image should be presented at the same time as the other content. So this is actually good, and we don't want to mess around with the decoding unless we know what we are doing. Okay, so by default we have to stick to auto. This is fine. For more advanced stuff, we can learn about when we are actually applying this particular concepts. That is fine. I think lossless JPEG WIF lossless compression is supported by WebP, supported by JPEG, not supported by JPEG. Okay, WIF it's supported, range it's supported. I don't understand how GIF has lossless compression. I thought it JPEG might have. Lossy though definitely it's supported by Webpack, JPEG and WIF. It's fine. What does the descriptor tell the browser about an image candidate specified in the SRC set? Intrinsic width of image, that is dimension of the image itself. Width of an image, that is dimensions of the image itself. Okay. So I don't understand this stuff. What does the intrinsic and extrinsic mean in this context? Let me go back, see what does intrinsic mean. Yeah, intrinsic mean this context. Yeah, okay, this is pretty smart. The browser needs to know that actual file dimension to make optimal choice, not how big the image will appear on the screen. So we actually don't care that how big of the image it is. We only need to know its dimension. Okay, that is good. Fine. What does the image tell us what image element is applied for? Given the dimension of the current viewport. This is fine. Video performance, we can actually do it in the next stream. Yes, we'll cover the video performance Optimize web fonts. Yeah, we can cover the video. I think we can cover in this stream as well. Let's, because there is not much in this particular blog. So the first one is, yeah, whenever we are optimizing for for videos, I think the first tool that we should be aware of is FFmpeg. This is the first tool that we can manually compress the videos down or lower the bitrate of FFmpeg. If you don't know FFmpeg, you should actually just search it out, FFmpeg. This is basically a tool that you can download to lower out the video stuff. Actually have this installed in my PC as well, I guess. FFmpeg. Yeah, I do have it. So you can use this, and if you have a good graphic cards or a good CPU, then this tool is really fast and will help you to shrink down the size of your images. This is a good tool, you can try it out. It's a pretty nerdy stuff, to be fair. So this is fine. We can actually give multiple formats of the image using the video tag. Either it's WebM or MP4, and not all browsers supports this WebM standard. So for fallback, we can give MP4. So that is one thing. The poster attribute. So what does this poster attribute? We decided poster attribute on the image. It tells you that the video contents may be what video contents may be before playback is initiated. So a poster is basically what the video is going to have. It's like thumbnail of YouTube channel, you can say it, something like that. And then we have features like autoplay and other stuff, full screen, autoplay, mute, loop. These are all the features that we can have in a video. But what about optimization? Where does optimization come into play for this particular thing? Some video include autoplay and just to, okay, instead of making a video something like this, we can create animated GIFs. There is one more optimization that we can think of. Instead of having a video, what you can create is you can create a animated GIF of that video. So this is actually pretty small in size and can save you resources, I guess. And yeah, we can use intersection observer to download videos once they are in the viewport. So that can be done as well. I don't recommend, to be honest, to use the videos directly in your website, because this is a very resource heavy thing. Whenever you use videos in your website, they are pretty heavy on resource, and I do not recommend them to directly use on your website. If you want to use it, do it via CDN. Load videos via CDN. I think that's the best way you can do it. User generated initiated playback. And the videos should be actually loaded after 1 or 2 seconds when your browser is loaded, when the page is loaded. After that, you load the video. Do not load the videos at the same time. Let's just say that I visited a website, let's say carwale.com, or some website which has a video. Let's see. Yeah, do they have a video? Somewhere they might have a video. Let me just go. Okay. Searching for a video. Do I get a video? Just give me a video. That's it. Give me a video. I want a video. Yeah. So these are the videos, right? But the autoplay of them is false, right? So this is fine. I think since I used to work here, I actually know a hack for the location. I think Puri is where generally nothing is there. Okay. Let me just try the STG version of it. Okay. So they are not allowing my IP address right now. It's fine. So what I'm saying is basically, if there is a video and there is a autoplay enabled on it, then load those videos after 1 or 2 seconds instead of directly loading to the user. That will save a lot of your data and all the stuff. The user will have a good performance, good overall experience. I don't still get why, what video performance are we talking about? Are we talking about reducing the bitrate in compressed system using codecs? So yeah, this is what it means. So if FFmpeg is the only thing, we should have a constant rate factors and poster attribute. What else we have? I don't think so there is much we can do in terms of video optimization. It's all in the FFmpeg that we can try to compress the video out or use the unlimited GIF. That's it. And the way we load the video, that is one more thing. Yeah, let me just cover it. Is there any other way that we can compress the videos out? Is there a way to compress videos? Okay, let me just say this to it. Let's just see what Claude says. I'm just giving it URL. So most likely it's going to again go over web FFmpeg. Is going to say use FFmpeg. Yeah, this is what it says. Perform compression. Use fallback videos. Yeah, this is where it's important. Preload control. Preload equal none. Don't download anything. Preload equal metadata. Only fetch video metadata. Preload equal none is the most desirable for user initiated playback. Only fetch video metadata. Impact. Video optimization can improve LCP. YouTube embeds block the mean thread for more than 1.77 seconds on median websites, impacting interaction to next bit. This is what I meant actually, that if you're loading anything, you do not want to load these YouTube stuff, whatever you are injecting, directly on the website. Do it after 1 or 2 seconds. That will save you a lot of time. I mean, you can show a fake. Let me just say what I mean. So you can have this particular video, and you can actually show an image like a thumbnail. And when user clicks on this particular thumbnail, let's just say there is a play button. There is a play button, something like this. I'm making a triangle, so there is a play button. When user clicks this button, then you load the video. Then you load the YouTube video. This is what you can do. Earlier, this is just an image. This is image. Okay, image with a thumbnail. This is your image with a thumbnail. And when user clicks on this particular button or overall this particular video, then you convert this to video. This is the best optimization that you can do in terms of video, and I don't think so there is anything else you can do in terms of video. This is the best optimization and best way to play video as far as I know. And teach me, enlighten me if you have any other method, but that is what I know. So this is good. We learn about video optimization, image optimization, resource hints, and resource loading today. Code split in JavaScript. This is a concept on its own, to be fair, and it's not something that we control. Majorly, it's controlled by Webpack and all thing. But do we have any? Yeah, we have a test knowledge, right? In order of resource elements inside a parent does not determine which video resource is ultimately downloaded. Yeah, I think it's true, I guess. False. The problem with this particular site is does not give you reason why this is false. And I've not completely read the blog of this. So let's just go and see why it was wrong. We need to understand every wrong that we get, not just the right ones. Right is fine. Also, let me think about this. When you multiple the browser evaluates them in order. This is what I thought at first. Supports and play. However, the question is asking if the order determines which video resource ultimately. Oh, yeah, of course. The order is not actually determining anything. It is dependent upon the browser. If it supports web M, then it is going to use WebM. If it supports MP4, if it doesn't support WebM and it supports MP4, then it's going to use MP4. I think that's the way it works. The video element poster attribute is considered an LCP candidate. It is true, I guess. That is fine. Next one is optimizing web fonts. We can do this in the next part. I guess I'll cover in the next part will be the last that I'll cover for the web dev. I think we only need to understand code splitting, prefetching, pre-rendering, and overview of web workers, concrete web worker use case. I think these are all the deep dives that we have to have, and the next session will be probably about 2.5 hours. Probably it will take around 2 hours of my time, but I think I'll complete this out either today or tomorrow, depending on the use case. So that's it for the vlog, for this particular video, I would say. learn about performance optimization, and there are a lot of stuff. You can check out this web dev, learn performance, and this will teach you more than you can learn with your teachers and everything up. So this blog post will teach you many things about web optimization, almost everything that you need to know as a front-end developer. I would say front-end or a full-stack developer. Even for a full-stack, this is a really good thing, because these are all the common questions that are asked in your coding interviews that I'm doing. Yeah, so this is good. See you guys in the next. Bye bye.